This is a recorded reading of weather fronts from the Weather and Climate Systems Unit. Weather fronts. Have you ever heard your local weather forecaster talk about weather fronts? Fronts bring changes in the weather. They occur when air masses of different temperature, pressure, and humidity conditions collide. A weather front forms along this boundary between different air masses. What you're going to do is you're going to circle weather fronts because that's a key term, and you're going to underline bring changes in the weather. And then over in the margin, you will write fronts occur when air masses collide. And this boundary, is called a weather front, which we'll talk about in our next section. There are several types of fronts. A cold front is a leading edge of a moving mass of cold air. When a cold air mass pushes a warm air mass ahead of it, the dense cold air slides under the light warm air, just as cold water will sink to the bottom of a tub of hot water. The warm air gets pushed upward. If there is a lot of water vapor in the rising warm air, dense cumulonimbus clouds form, and rain or snow may fall. If the rushing upward of moist air masses is violent enough, there may be lightning. Scientists are still not exactly sure why lightning occurs, though they do know that positive and negative charges separate high in the storm and cloud. If there is little water vapor, clouds form but do not produce storms. Cold fronts frequently move fast and cause abrupt changes in weather, including violent thunderstorms or tornadoes. After a cold front passes, cold, dry air moves in. So in the first part of that paragraph, it's talking about a cold front, and that cold front is when a cold air mass moves into a warm air mass. If you look down at this picture, there is cold air advancing into a warm air mass. And what it does is it thrusts up the warm air mass. And if this is violent enough, it can produce lightning and thunderstorms. Also, if there's a lot of water in this warm air, H2O water, you create these tall storms. If there's not a lot of water, you just create little clouds, and that's low water. And a warm front, a moving warm air mass, overrides a cold air mass ahead of it. The warm air mass is less dense, so it slides over the cold air. If the warm air is dry, scattered clouds form. If the warm air is humid, rain or light rain or snow in the winter normally falls along the front. Warm fronts typically move slowly, so rainy weather usually stays around for days. And what you can do is you can circle warm front, because that's another term we'll be learning today. And that's when a warm front happens when warm air mass overrides a cool air mass. So the warm air mass is moving faster and it takes over the cool air mass. As you can see here in the picture, our warm air is just going to kind of slide up on top. It won't be abrupt and violent like the cold air mass coming in. It's going to be much slower. If there's lots of water vapor in these clouds, you're going to get all day rain. If there's little water vapor, you're just going to get lots of clouds. So the water vapor, the amount of water vapor inside those air masses determines if there's going to be rain or not. The next thing I want you to do is copy these images with colors onto your guided reading. All right, and then we're going to read the exit slip to practice. It says, what frontal conditions are most likely to produce a thunderstorm? So if you notice they're using the word frontal. Okay, frontal is the adjective of front. So it's asking you what front is likely to produce a thunderstorm. And the correct answer is a cold front. And how Basically, that cold air mass will move into that warm air mass and force it up to produce tall clouds with thunder and lightning. This is a guided reading for weather fronts. If you have any questions, ask your teacher.